Okay, today we are going to talk about how to plot the trig sine cos functions with the transformations. So I'm going to show you one method. You can use any other method you want, table of values, you can use the mapping rule. But there is one thing that you have to show me. What will happen to the major points of the parent function when you do the transformation? And this method shows me exactly what will happen. So the first example that we are going to do is something like y equal to, let's say, sine x. The question is that how are you going to plot this function? This is a parent function. There is no transformation on this guy. Now, the first thing you always do is to find the amplitude of your function. To find the amplitude, find the coefficient which is to the left of the sine or cosine. And you can see the coefficient is 1. So automatically we know the amplitude is 1. So I'm going to write 1 here. That's my amplitude. Okay? The second thing you have to do is to find the period. Now, in general, when you have y equal a sine b times x minus c plus d, as we said before, a is your amplitude, c is your phase shift, and d is vertical shift. So d is vertical shift. Let me write it. C is the phase shift, PS. B helps you to find the period. Remember, this is not period. This helps you to find the period. And A is called the amplitude. Okay? These are the 4 constants you need from any sine or cosine function. If I look at this y equals sine x, you can automatically see that A is 1, as we said before. So the amplitude is 1. That's the first number I found. Now, to find the period, you take the b value, and then you divide 2 pi by b. So you say period, in general, is 2 pi over b. And what is 2 pi in degrees is 360 degrees. So this is really equal to 360 degrees divided by b. Now, let's go back to this function. What is the number to the left of x here that you don't see? It's 1. So we automatically say that for this function, y equals sine x, the period is 360 divided by 1, which is going to be 360. So I can say that period is 360 degrees. Now the next parameter that we are going to find is phase shift. Phase shift is the number which is inside the bracket here. This is your phase shift, C. Okay? Now, if C, this, which is the general form, is negative C. If C is positive, you move to the right. If it's negative, you move to the left. Now, looking at this example, do you see any number inside the bracket with x? No. So what is the phase shift? 0. So I say phase shift is 0. Now, vertical shift is the number that you add to the sine. Do you add any number here to sine? No. So what is the vertical shift? 0. Excellent. You always have to have these 4 numbers written underneath your graph. Now, how are you going to plot is very easy. Look at your period. The period is how much? 360 degrees. So I'm going to assign this guy to be 360 degrees. Now I'm going to divide this interval into 4 subintervals. So I'm going to divide this one by 2. What is 360 divided by 2? 180. Excellent. What is 180 divided by 2? 90. Now, how much is this one, you think? 270. Excellent. Now, we are dealing with sine curve. What is the value of sine when x is 0? 0. So this is the property of sine curve. It always starts at 0, then it goes to the maximal, then it goes to 0, then it goes to minimum, then it goes to 0. Agreed? This is sine function. Memorize it. So I start from 0 here. What is the next point I'm going to go? To maximum, right? And remember, the amplitude is what? 1. So if this is 1, this is negative 1, I go to maximum in between, which is 90 degrees. Okay? What is the next point I'm going to go on sine function? 0 on a 180. What is the next point? Negative 1, which is the next one, 270. And what is the next one? 0. And now connect these points with a smooth curve. Okay, when you are plotting sine curve, always find the period. Then divide the period into 4 units, sub-regions. So 360 divided by 2 is 180. Then again divided by 2 is 90. Then it's going to be 270, the other half. Okay? Now the sine curve always starts from 0, goes to maximum, goes to 0, goes to minimum, goes to 0. This is how the sine curve behaves. Now, my beginning is 0, which is here. Then it goes to the maximum, which is here. And the maximum here is the amplitude of your sine function, which is 1. Then it goes to the 0, which is here. Then it goes to the minimum, which is here, negative 1. Then it goes to the 0. So this is my y equals sine x, which is not really that hard to do. And you already knew it beforehand. But this technique, you can use it to plot other sine functions, which they have the transformation applied to them. Let's say that this time I ask you to do y is equal to 2 sine 2x. Okay? No, I'm sorry, because in this, yeah, we don't do. Let's say I ask you to do 2 sine x plus 45 degrees. Okay? So, again, I'm going to dissect my sine function and determine the values for A, P, PS, and VS. First of all, what is the amplitude here? 2, because the number 2 here tells me how much is the amplitude. So this is 2. Okay? Now, what is the period? Again, to find the period, I'm going to divide 2 pi by the value of b. But b is the number which is multiplied by x. The number that you see here is 1. So you say 2 pi divided by 1, which is 2 pi, which is in degrees 360 degrees. So I say my period is 360 here. Now, looking at this one, what is the phase shift here? What is the phase shift? Negative 45. Excellent. Because the formula is minus c. You just take this number here, and then you flip the sign. So it's going to be negative 45. So the phase shift is negative 45 degrees. Now, what is the vertical shift? 0, because there is no number added or subtracted from y, which is 0. So the vertical shift is 0. Now the question is that how are you going to plot this guy? Very, very simple. The way we do it is that we are going to divide this one. Let's say this is 360. Okay? Again, I'm going to divide it in 2. So this is going to be 180. This is going to be 90. And this is going to be 270 degrees. Okay? Now, let's plot. Forget about the phase shift here. Just consider the function y equal to 2 sine x. No phase shift, no vertical shift. Okay? Agreed? Just consider this function. How do you plot it? We know that this function, the amplitude is what? 2. So this means that this is the maximum it goes, and this is the minimum it goes. Now, how does the function sine x, remember, this is 2 sine x. How does this function behave? Start from 0, goes to maximum, goes to 0, goes to minimum, goes to 0 again. So it's going to start from 0. What is your maximum in this case? 2. So at 90, it goes to 2. Then it goes to 0. Then it goes to -2. Then it goes to 360. These 5 points, right? Now I'm going to plot this one with a dotted line. This is not the function yet, guys. This is just the base function, 2 sine x. Okay? Now I have to consider these two now. The vertical shift and phase shift. What this one says is that every point on y equal 2 sine x is going to go to what? Left or right? How many degrees? And how many units going up or down? 0. So this means that I start from the origin. I go left 45 degrees. But remember, 90 is this much. So if this is 90 degrees, 45 is somewhere in between. So it's going to be here, this point. So this is the transformation of the origin to the left. Okay? Now let's look at this point now. Do the same thing. Go to the left 45 degrees. So it's going to be this point, which I'm going to show with a cross. Better to use the cross. Now go to this point, 180. I go to the left 45 degrees, which is this point. Now go to this point, the third point. I go to the left 45 degrees. So it's going to be this point. Then go to this point, 360. Go to the left 45 degrees. Now connect these crosses together. This is going to be your final curve. So it's going to be something like this graph. Now let's find the coordinate of the transform point. What is the coordinate of the origin before? Before here, 0, 0. But here I just moved left 45 degrees. So what is the new coordinate? -45 and 0. Okay? Now let's look at this point. What was the coordinate of the point here? 90 and 2. I moved to the left 45 degrees. So what is the coordinate of this guy now? 45 and 2. Let's look at this point. What was the coordinate here? This coordinate was 180 and 0. Now if I move 45 to the left, the coordinate becomes what? 135. So this one becomes 135 and 0. Now let's look at this point. What was the coordinate here? 270 and -2. So if I move 45 to the left, I get 225 and -2. And the last point was this guy, which was 360 and 0, right? Now if I move 45 to the left, I get 315 and 0. So in your test, what you have to show me is that you have to show me the transform graph, which is this graph, and also the coordinate of these 5 major points. And very easy, you can just subtract and add, and find the new coordinate system. And that's it. Okay, in this example, again, the amplitude, as you can see, is equal to, what is amplitude? 3. The period is 2 pi divided by b. What is b? What is the coefficient of x? 1. So the answer is 2 pi, which is 360. So my period is 360. Phase shift is the flip of the number inside the bracket. Plus 30 becomes -30. And vertical shift is the number that you add or subtract from cos or sine, which is -1. Again, the first step, forget about these two transformations. Let's plot the base graph. The base graph is a cosine. Maximum is 3, minimum is -3. So I'm going to have, first of all, the period is 360, so this is 360. divided by 2 is 180, divided by 2 is 90, and then this one is 270. Now the maximum is 3, okay? So this is 3, this is 2, this is 1, -1, -2, and -3. Now, I'm going to plot the graph of the base function, which is y equal 3 cos x. We know that cos has the property that it starts from maximum, then it goes to 0, then it goes to minimum, then it goes to 0, then it goes to maximum. So it starts at maximum, 3. Then it goes to 0, which is here. Then it goes to minimum, which is here. Then it goes to 0 again. Then it goes to the maximum. This is the property of a cos function. Again, I'm going to plot this one with dotted lines, which means that this is not really the cos function, but this is the base function. Now I'm going to apply every transformation which is here to every point on the graph. I'm going to start with the first point on the left, which is this point. We know that this guy has to go 30 degrees to the left and 1 unit down. So if this much is 90, so this is -90, 30 units to the left is going to be approximately here, 1 unit down. So I'm going to get approximately this point here. Okay, I'm going to show it with a cross. The next point is 90 and 0. Again, I go 30 degrees to the left, 1 unit down. So I'm going to get a point like this one. The next point is 180 and -3. I go 30 degrees to the left, 1 unit down, which is going to be -4. So I call this one -4. The next one is 270. I go 30 degrees to the left, so it's 240, 1 unit down, which is going to be -1, which is going to be here. Okay? And the last one is going to be the 360 here, which is 360 and 3. I go 30 degrees left and then 1 unit down, so I'm going to end up to somewhere around here. Now I connect these points together and I'm going to get a graph like this one. Again, this is an approximate, graph. Now, I told you I need the coordinates of the point. This point used to be 0 and 3, now -45, -45 and 2. Oh, I'm sorry, -30 and 2. So it's -30 and 2. Now, this point used to be 90 and 0. Now it becomes 45 and -1. So this point is 45 and -1. This point was 180 and -3. 45 to the left is 145. And the coordinate becomes -4 for y value. So this is 145 and -4. This point was 270 and 0. This one becomes 235 and -1 because you went 1 unit down. And this one, this point was 363. Now if you go 45 to the left, you get 335 and 2.
So it's not 45.
Oh, it's 30. I'm sorry, it's 30. All these degrees, please change it. I was thinking of 45 degrees. So it becomes 330 and 1 unit down, which becomes 2. So please remember, these are all you have to subtract 30, not 45. Okay, the last example, y is equal to 2 sine 2 times x plus 15 minus 1. Again, the amplitude is the coefficient of sine, which is 2. So the amplitude is 2. To find the period, we are going to use the value of b, which is here, which helps us to find the period. So we say period is equal to 2 pi over 2, which is going to be pi, which is 180. So the period is 180. Now, to find the phase shift, get the number which is inside the bracket, and then flip the sign. So the phase shift is negative 15 degrees. And the vertical shift is negative 1, going down. Again, ignore these two last columns. What I'm going to do is that I'm going to plot the basic sine function. Again, the period is 180, so I'm going to take this one as 180. This is going to be 90. Divided by 2, this is going to be 45. Divided by 2, this is 135. Now, the amplitude is 2, so the maximum is 2. And the minimum is negative 2. Now, this is a sine function. We already seen the pattern of the sine function. Starts from 0, goes to maximum, goes to 0, goes to minimum, goes to 0. So I'm going to start this point. Then I go to maximum at 45. Then I go to 0. Then I go to negative 2, which is the minimum. And then I go to 0. So my base function is going to be the dotted graph, which I have here. So this is y equal to 2 sine 2x. Now, at every point on the graph, the base function, I'm going to apply the transformations. Going left 15 degrees, going down 1 unit. So I start from this point, which is the origin, this point, and then I go 15 degrees left and then 1 unit down. But remember that this one is 45, so this is going to be negative 45. So 15 is going to be 1/3 of this unit, and then 1 unit down is going to give me this point, which is going to be shown with a cross. Now, the other point that I'm going to look is this point. I'm going to go 15 degrees left and then 1 unit down. So it's going to be 15 degrees left and then 1 unit down is going to give me a point which is here. Then I'm going to go to this third point. Again, I'm going to go 15 left and then 1 unit down. So I'm going to get a point somewhere around here. Then 135, I go to 15 left and then 1 unit down. So I'm going to end up somewhere around here, which is negative 3. And then the last one, 180, I go 15 left and then 1 unit down. I'm going to end up somewhere around here. So I'm going to connect the points together and I'm going to get a graph like the following. Now, the last thing you have to do to get the full mark is to show me what are the coordinates of each point. Okay, for this point, I know that is the transformation of 0, 0. So if I go 15 left and then 1 unit down, obviously this point is negative 15 and negative 1. Then I go to this point. This is the transformation of the point 45 and 2. So if I go 15 left, I get 30 degrees. And then 1 unit down, so I get 1. The next point is this guy, which is the transformation of 90 degrees and 0. So if I go 15 left, I get 75. 1 unit down, I'm going to get negative 1. So this is 75 and negative 1. And remember, all these are degrees. The next one is this point, which is here. This is the transformation of the point 135 and negative 2. So if I go 15 left, I get 120. And then 1 unit down, it was negative 2, so it's negative 3. Again, this is degree. And finally, the last point is this one, which is the transformation of 180 and 0. So if I go 15 degrees left, I get 165. And 1 unit down, I get negative 1. Again, these are degrees.